we're going to look at this problem, problem 25 from the 2025 AMC 8. It's a really, really cool problem with a very useful shortcut in it. So let's just go through the problem. So there is this lady, Michaela, and she's trying to find all the possible ways from like the bottom of this diamond grid to the top. So she's drawing all these routes in. Here's an example of one route. This is maybe another one. Maybe this is another one. And then what she's doing, she's working out these areas. And then she wants to find the sum of all of the areas determined by all the possible paths. So the paths, by the way, can't loop back on themselves. They can't do something like this. They have to be paths that either go like this, like a kind of zigzag, but always work towards that. So let's have a go at this. Now, the first thing that I would do to solve this is I want to try and make it a little bit easier to understand. And sometimes the way that you look at a problem massively affects how easy it is to solve. So I decided to turn this on its side, and then it's a grid that I'm more familiar with. And then instead of being this kind of northeast and northwest, like it says in the question, now we simply have to the right and we have up. Now, if you spend a few moments thinking about the problem, you'll realize that it's completely impossible to count these by hand. And you can kind of see like the numbers involved are so big, there's got to be some sort of calculation. So the way that I thought I would go about this is that I would try to count first just a number of paths. So what we need to think is that because we can either go up or right, and there's 5 ups that are needed and 5 rights, really what this becomes is a problem where you've got, I've got 10 spaces. How do I put in all my ups? And then where do I put in my rights? Okay, now, if you've studied your combinatorics well, you will recognize that this is just a combinatorics problem. How do I choose 5 things out of 10? So we use the choose function, like the binomial coefficient. We do 10, choose 5. 10 choose 5, of course, is 10 factorial over 5 factorial over 5 factorial. I'm going to try and simplify this by hand. I recommend that you have a go at trying to do this as well. No matter how good you think you are at doing it, finding the shortcuts, knowing how to do this automatically is really, really useful. Okay. So let's take the 5 and the 2 will cancel with the 10. The 3 will cancel with the 2 there. And then the 4 cancel with that, you get 2. And then you're going to end up with 2 times 2 times 2 times 7 times 9, 2 times 2, so that's 28 times by 9 equals 252. So there are 252 of these paths that somehow zigzag through. All right? So now we need to try and work out the area of them. The problem is they all have different areas, but there's one really useful, cool symmetry trick here, which I really like. And this is the essence of the whole problem. So this is a bit that you really want to kind of pay attention to and see if you can transfer to other problems. This is the really interesting bit. We know there's 252 paths, and now we need to work out their areas, but their areas are really, really different. But if we look at what happens when you actually cut up a grid, you actually cut it into 2 parts, A and B, and both of them are the sort of areas that we want to count. Now, they change. A can change. If A gets smaller, then B gets bigger. If B gets bigger, A gets smaller. But together we know that A plus B is actually always equal to 25. And we know that each B comes with an A, and each A comes with a unique B. So these are all the solutions together. This is what's really, really smart, is we realize that actually, if we count all of the possible A's together and all of the possible B's, so there's 252 of them, and then we add them all up, well, every A and every B makes 25. So if we just do 252 times 25, we will have counted every A with every B and every B with every A, which means that we will have counted everything twice. So then we need to divide both sides by 2, and then we've counted everything just once. We've counted every B just once. So let's do this. What's 252 divided by 2? Well, that's going to be 126 times 25. Now we can use the old trick where you double one, halve the other. So this is going to become 63 times 50. And then it's going to be 31.5 times 100, which is finally, of course, going to be 3,150. And that is the answer. If you feel like taking this a little bit further, I would say the natural place to go would be to see if you can do this for a 6 by 6, and then once you got the hang of it, just do it for an n by n and see if you can get a formula for it.